call this
แต่ถ้าเขาอยู่ตรงกัน
when you have a bad signal first and you invest, how likely you're gonna pass?
โอ้ไม่ร่วงฝั่งนี้ก็
How we write it out as like a formula?
แต่มันเป็นอย่างนี้นะแต่มันจะไม่เห็นหรอ
P Okay, P pass given bad, right? Obviously, we don't know that yet. What do we know that you think are relevant?
0.7
0.7 is bad. Okay, we know that bad is right? P bad is 0.17.
นั่นเราคิดแบบอะไรบ้างครับไม่เห็นอะไรบ้าง
Remember how we had an example of like probably of getting a rain is when it's rain and humid, rain and cloudy, rain and happy, rain and everything, right? In this one, we know that past. Okay.
ก็แบบเป็นอย่าง
Past is 25% no matter what, right? So technically from here, what do we know? We know the P of past is 0.25. Whenever you're confused, just replace the word past with rain or something. So it remember you remember what it means. So it used to be type of rain is rain and humid, rain and cloudy, and blah blah blah. What should we say for this case?
How did you get that?
That's the real pun, right? Okay, pun.
How did you get the P plus point?
Oh, it's come from here. This is the original tree we have from before. Does it make sense where 25% comes from? It's from 2 weeks ago. It's given. It's given. That's what I meant. Okay. The same idea with rain and cloudy, rain and stuff. This is means it's equal to
it's
past and good and past and bad, right? Because there's only two scenarios in the world: bad or good signal. Does it make sense? This line? I just come from probably of rain is like rain and humid and rain and cloudy. I just changing to probably of passing is like pass and good plus pass and bad. Because the test can only give you good or bad. Okay. But from the slide before, when I got a board before, whenever you see this, whenever you see things happen together, you can scream for a second, but it's not that bad, right? You know that you can actually use Bay rules to kind of move things around. Because whenever you see a joint probability like that, like pass and good. Oh, if you use Bay rules, what is it? Change to another color. This thing is the same as P. Oh my goodness. Can you read this? So what is this? It's like P of pass given good times P of good, right? The way to show like why this works is what is probably of pass given good? Probably of pass given good is probably of pass and good together divided by good. And so if I move things around, it looks something like this. Okay, I'll draw it here so that P of pass given good is P of pass and good happening together divided by probably of good, right? This is our friend base rule. So if I want to know this thing, it's basically just pass and good is P of pass given good. I just like move this thing up here and you get P good.
เข้าใจ
Good, bad. You can give signal. Okay, good. So now we happy, right? Every time you see a job probability, we not too stressed because we know that we can always turn into this kind of form. So if I come back to this board, right? That's why pass given good is that thing that we just had. So let me do the other one too. So this thing would be what? P of pass given bad multiplied by probably of having a bad signal, right? Yeah. Hopefully you have more space than me. Putting this together, let me clean it up. Okay, so P of past is P of past given good multiplied by variable good plus P of past given bad times P bad.
Hello.
Yeah. In this equation, how many of these do we know already? We know past, right? What was past again? This is 0.25. What else do we know?
Bad.
Really good.
Good is 0.3, right? This is 0.3. Bad is 0.7. Okay. Oh, this is crazy. Yeah. What else do we know?
As you
Past given good. Okay, what is it? 2/3, right? Was it 2/3? You have this thing that you don't know what it is. Right? Everything else we know. When you have an equation and one thing you don't know, you can solve for it, right? So if you solve for this, what do you get? I think something like you get 1/14. This is just moving things around to solve for the variable that we care for. Before I switch back, does this case make sense? This is the rain story. I just control F and then change the word rain to pass all the time. Is this one we actually want to find? Pass given bad? That's what we want to find, right? Pass given bad. We know that this is 1/14. Do we know this one then? It's going to be 5. No, not 5. What is the fail probability? If we know that pass given back is 1/14, 14, right? Okay. Phew. That's it. We did it. Yay. Well, I did it. You guys helped me did it. Questions. This is the last math we're gonna do today. We can do more if you want. Yeah. Okay, I see some requests for more math. Mukha, what's up? Yeah. Which variable? This?
The one that 14.
Okay. Where did we get 1/14 from?
Yeah.
So if you come back to this one, right? We want to solve for this equation. This is our question mark. We actually know everything else. So if you move things around, right? This square thing is equal to what? It's gonna be 0.25. What happened? Minus this thing, right? Minus 2. Minus what? Minus 2/3 times 0.3, right? Divided by 0.7. Yeah. They don't have calculator. Do you get 1/14 as well?
มองไม่เห็น
That's how we get 1/14. This is probably the hardest thing you've ever seen for this class for my part. Everything else is much nicer. That's why I want to go slow today on this. Any questions? We're not gonna solve for this because if you put in all the numbers, what is the next step again? We can solve for the you can solve for the upside value, right? So without you doing that, so you would get something like this, right? This is what we had. If you recall, what we would have to do is to solve for expected value. So we're like, okay, for invest, we can find expected value. You can try to do this at home. you can take the VAT numbers and you can check it later, right? I just do it quickly for you. You solve for exit value, you get 160 up there. So you choose it over abandon. Down here, you find that expected value is minus 54. Should you invest in that case then?
Is it the same?
No, right? If you get a bad signal, investing give you minus 54 millions. So you choose to abandon. The bottom one, you already solved it before, it's the original tree. So in the end, right, you multiply with terms good and bad, you can find the values. So testing give you the expected value of 48 million. Not test, you get 10 from original tree. So should we test or not test then? We should test, right? So we should do the test because it give you $48 million. Now, this is what we call EVSI. Last time we have EVPI. What is the value of getting perfect information? How much you want to pay for the perfect fortune cookie, right? This time you can see it's not a perfect forecaster. It still give you some signal, good or bad. But you can still put some numbers on it, right? So even though test is 48, what is the exact value of testing then? It's not going to be 48, right? Because had you not test, you could go get 10 million already. So similar idea to the EVPI last time. The EVSI, exact value of sample information, it's just going to be the difference between these two. What is the value you get from testing versus what if you didn't do the test? What would you get already anyways? And so we get EV. If you remember from last time, EVPI was 60, EVSI was 38. So one thing you would see is EVSI is never bigger than EVPI. Like it usually less than, it can also be equal, but it cannot be bigger.
Yeah, I know.
Any intuition why EVSI can never be bigger than EVPI? Again, EVSI is how likely how much you want to pay to get this test result. EVPI is how much you're willing to pay to get perfect future knowledge. So if you try to get perfect future knowledge, it should always give you higher value, right? Because there's no uncertainty left at all. And that's why EVPI always larger or equal to EVSI. It's a lot. So make sure you have some time. It's still a lot of time before the midterm. Try to kind of go through this by yourself again. Okay.
Maybe it's not you.
Sound good? Okay, let's say goodbye to math because I'm so tired. Just kidding. I love math. We still can do math the whole hour. Let's move on to the last concept in this class, which is about system design. Okay. By the way, if you recall, you guys have a team project with your team, right? And we asked you to vote when you want the deadline to be, and majority of you voted to make it due right after the midterm. And so this assignment that you get to use the concept from today into building a proposal is going to be due the Sunday after the midterm. Because of this, I'll try to make my midterm parts a bit easier because you have to spend time on this as well. Okay. So what do we have to do? In the next hour or so, we're gonna learn from Kinun and myself on system design concepts. Each of the components we're gonna teach you, we're gonna ask you to apply your idea that you came up with your team using these components. Feel free to share your idea, but try not to. Or I always try to encourage you to put your project seed or something else you're working on, right? Because we want this to be useful for you, not just for our class. If you have an idea, a project, you can also use that in there. We want to ask you to build presentation slide as a PDF. So you can use PowerPoint, you can use Canva, anything, just export as a PDF. There is no minimum or maximum pages. And only one person in the team needs to submit. How are we going to grade this? We're going to grade by completeness. You did all the components we asked you for, the quality of the work, and the effort you put. If you be quite creative in how you use the cost concept, we'll give you an extra point as well. If you want more information, there's a QR code. This is also linked from my course view, so you can also click from my course view to see information. Okay, without further ado, let me introduce you to our guest speaker for today. She is a system engineering expert. Let me introduce you to Pinun Kasina Ushukamunshai. Yay! She did her undergrad at Harvard University, and then she did her master's at CMU focusing on robotics. She had amazing work experience. She worked for Jukes in Thailand, Deliveroo in the US, Facebook in the US and UK. And she's now had a toy startup called Tinker Maker, which we're going to show you a little today. And she's very special to me. Actually, we go way back. This is us back in high school. So we friends from a long time ago. Okay, so let me move to Pinun for this. Let me switch over to her slides. By the way, Pinun at the end will pick top 10 people she very impressed with, and you get extra midterm points for that. So
Please answer questions.
pay attention at least. Okay. Oops. Okay, let me pass over this clicker to you. I'm gonna try to do it like people will be mainly teaching you this, but I will do it like a little Shami style. I'll try to help support her a little bit. So she's sorry, I'm Kibai. Okay.
Okay, hi everyone. Hanoi Mashna. So I'll be going through a deep dive of systems engineering with you today. So Pippa told me that he already went over with you what a system is. So let's do a little bit of a recap. Who can tell me what a system is?
Cassie.
Our system is like when you take inputs and then you go through a process and then it turns it into an output.
Yes, definitely a system does that. Does anyone else have anything else to add?
Okay. And your name is?
Vicky,
Okay.
a set of connected parts that work together to create an outcome.
Yeah, that's definitely a key. So I'm gonna go over it now. So it's a set of interrelated components or elements, and they have to work together in order to achieve a specific goal. And usually in a system, you will have constraints. You have a defined environment, and the system has to be able to work under these defined environments. So do you know how a system is different from a product? Yeah,
I think product is what you create from the system.
possibly. Anyone else?
I think product might be just a part of the system.
Definitely. So a product is usually, I mean, a system can be a product, but a product doesn't necessarily have to be a system. So let's go over some examples of systems. So like a robot, like a vacuum cleaner, or a reforestation robot, or any electronic device, definitely a system. Application, anything on your phone is a system. A bicycle is a system. A car engine or a music instrument like a piano or a board game or a watch, these are all systems. But can you think of anything that is just a product but not really a system? Remember that system has to have many components that work together.
So the key to be a system is have multiple parts, right? So people ask, you think of a product that is not a system?
Computer.
Computer is definitely a system. It has like hardware and software things inside it that have to work together in order to work for you. So if you have a cup is probably not a system because it only has one function and it doesn't have many things working together. But actually most things around you are a system.
Add something.
Sure, yeah. Definitely a product, very useful, but it's not a system.
Mango.
Mango.
Not a system. Okay, so what is systems engineering? Yes.
how to connect designs those connections on purpose.
Okay, yes.
Yeah, for sure. So, to go over it, systems engineering is like a tool that you use in order to design and manage systems, in order to meet requirements. Because when you create a system, you usually have a lot of constraints, like you might have a really tight timeline or you don't have a lot of budget in order to create the whole system. So you need a tool such as systems engineering in order to help you with the design and implementing your systems in order to meet the requirements. So today we are going to go over the key elements of systems engineering. There are use case, requirements, functional architecture, cyber physical architecture, trade-off analysis, project management, and risk management. And we are going to be going through all those key elements using two examples. One is a reforestation robot, which is the robot that I worked on at Carnegie Mellon. And the other one is a language learning app or Duolingo that you might be familiar with. When we go over Duolingo, we are going to go over it together as a class. So I go through an example with reforestation robot with you, and for Duolingo, we do it together. You help me and keep up.
By the way, do people know what Duolingo is? Anyone use it frequently? I'll show a quick intro video on what it looks like. So if you never used it before, you get a sense of what it is. Which language you guys do, by the way? You know how they do music and chess teaching now also on Duolingo?
This is Duolingo. Around 34 million people use the language learning app every single day, some for well over a decade, making the company around $500 million annually and making it one of the top education apps in Apple's App Store for the past decade. And yet,
most people who use Duolingo do not pay.
all of its lessons are completely free to access. Only around 9% of its users pay, and less than 8% of its revenue comes from advertising. So, how does a free educational app manage to also have a valuation of $7.7 billion? And is the company's strategy sustainable? The answer lies in AI, A/B testing, and this little green app.
All right, we're gonna see some of this over today as well. All right, back to you, Franklin.
Okay, so first element is use case. So when we create a system, we should define a specific use case or multiple use cases on how we are going to use the system. So when we define a use case, we should think of who the user is and then how the user is going to interact with your system and what goal is the user is going to achieve. And this is gonna help us capture requirements in order to ensure that the system meet the user's needs. So let me go over an example with you. For a reforestation robot, let's imagine an uncle. His name is Lucas. He has a lot of land that he doesn't use, and a lot of it is pasture land in Pennsylvania. And he would like to turn this land into something useful. So he's thinking about turning this land into a forest. But he doesn't want to spend too much money into investing reforestation. So this is where our robot comes in. So our robot actually costs a lot less than hiring foresters to manually plant forests. So Lucas will rent our robot, and our robot is going to go over the land and plant seedlings all on its own. And at the end, after it finishes all the planting, it's going to report what plants it has planted and how much carbon dioxide it has absorbed from the atmosphere. And this data is going to be reported to Lucas so that he knows more about the forest that he has planted.
So I think what you notice here, right, it's not just like what would this product do, but it's actually the whole story of like why someone when they use a product, and you can see it touch on multiple features and the function that product can do.
Yeah, the key is to be very specific of think of a real user and how would that person actually use the product or the system. So let's try doing this with Duolingo. Can anyone come up with a specific use case? Think of like an example, user, maybe your friend. Why would that person want to learn language?
Learning. Use the mic as well.
I think the person who use Duolingo is the person who wanna learn new language to use it like when they traveling they wanna speak other language.
Do you want to name a person?
Um,
Because we need to make it a drama, right? You guys love drama.
Mark.
Okay, who's Mark? Marco? Oh, sorry, Mark.
I studied Japanese with Duolingo.
Ah, so Mark travels. Okay, Mark travels and one of the languages. Can you make any comments?
I think this is a very good use case.
Okay.
I think when you speak like the person that like when you go to other countries and you speak their language, it makes you more like connected to that person. Like,
Okay. So not only one of them because of travel, but you want to feel connected. Okay. Marks want to feel connected.
To the culture and history,
Okay.
maybe that is
Okay. To culture and history.
right. But let's imagine more more specifically how Mark is going to use the app. Like what features on the app might Mark be using in order to learn the language?
like
Sorry.
like learn how to pronounce.
Okay. So it's the pronunciation.
Like maybe basic conversation.
Where are you?
Jen, right? Okay. What's the
Maybe you want to learn some basic conversation. Maybe order some coffee, greeting people.
Okay.
okay?
I think this is pretty good. When you do your assignment, don't forget to be very specific. It's going to help you think of the whole assignment much better.
And try to make sure you touch on multiple kind of feature as well, right? You can say, oh, Mark, after he came back, he like applied to Basai, and he English score for Basai, and so Duolingo also now have certification where you can get English score through Duolingo. Okay, awesome.
We're going to
Awesome.
go over the next key segment of systems engineering, which is requirements. Requirements are actually very, very important. Maybe one of the most important things when you do systems engineering. And basically, you need to understand what your system is going to do and what it is required to do. So when you write your requirements, you need to define the functions and the features as well as the constraints that your system must satisfy in order to meet the stakeholders' needs. Stakeholders are different people. Your users are definitely one of your stakeholders. You, as an owner of the project, can be a stakeholder, and maybe you are funded by some investors, and they may be your stakeholders as well. So all these needs have to be met, and it is met through defining your requirements. And there are many kinds of requirements, including functional requirements, performance requirements, and non-functional requirements. We'll be going over these in the next example. Okay, for the reforestation robot, first the robot has to identify location where to plant. And then once it gets there, it has to deposit the seedlings. But on the path going there, it also needs to avoid any collisions. And before it actually start planting anything, it also has to optimize the path that it is going to run. And next, it has to be able to accommodate seedling variety because different plants have different sizes of the seedlings. And lastly, we have to make sure that the robot will be able to traverse pasture land or the land that it is going to plant trees on. So the key thing in thinking about your requirement, which these are functional requirements, is what is the robot going to do? So when you write your functional requirements, it should start with a verb because that's what the robot is going to do. And then next, we have performance requirements. They are very, very closely related to functional requirements. They are basically doing the same thing, but in your performance requirements, they will be more specific about numbers. For example, in the first one, in functional requirement, the robot has to identify locations where to plant. In your functional requirement, it adds number into your functional requirement. It has to identify locations over 10 acre of land with 1 meter of precision. So your performance requirement will be able to help you quantify your functional requirements better. And the last kind of requirement is non-functional. This one is what your system is, and it is not what your system is going to do. So for example, our robot has to be cost effective. But cost effective is not a verb, right? If it's a verb, then it is probably your functional requirement. And our robot has to be rugged and easy to use and safe. And if we want the robot to be yellow, like in the picture that we show you, that will be your functional requirement as well. Do you have any questions here before we move on? Okay. So I always click the wrong button. Okay, let's try to do requirements for a language learning app.
Let's start with the functional one then. What do you think would be a functional requirement for Duolingo?
I think it should get a sound when you want it to pronounce.
So always start with the verb. What would you think the verb, the simple verb that it does things?
Produce the sound.
Produce a sound.
Oh,
Okay. Okay.
this is fine, but it might be a little bit too low level. Let's try to think about what you want it to do more specifically for your system.
Cream.
Tracking your progress.
Track progress, okay, that's good. Excellent.
Noah.
Train to reading, writing, listening, and speaking.
Train. Sorry, what's the verb?
Trains,
Uh-huh. Reading, writing, and listening.
speaking.
Excellent. Okay. Yes. Okay.
5 minutes.
Mhm.
What's your name? Vera.
Like it.
Okay. So anything else you want to add, Dr.
Yeah. We need first. Okay, each incident.
Gen Y. Gen Z.
And what's your name? What's your name? Oh, I said give feedback.
Okay.
It's a
Okay.
okay.
Let's move on.
So I think these are all really good. So maybe we should try to do we should try to do performance requirement for all these functional requirements that you have come up with.
Again, recap, right? Functional was the simple verb. Performing, it's like, let's add numbers. Let's add some metric, KPI, kind of to this.
Right.
So let's pick one of these and then add numbers. No name. Which of these functional you want to expand? You want to expand? You should expand from this. Yeah. Anyone else want to try? How?
Like track progress and like it's like personalized, but the more you use.
Uh-huh.
Yeah.
So how will you quantify that with numbers?
Remember? Like I feel like for example, like if you use like if you like answer but for example, like when you like answer correctly, like the level like getting harder, so like you get to learn more. But if you answer like incorrect, then like it will move back.
You know, maybe you can give an example. Like if you pick one of these and you add numbers, what would it look like? Produce a sound. Okay, maybe not.
Uh,
T scenario.
yeah, so
Okay.
I think maybe in, for example, teach with scenarios, we can say that teach with scenarios for 40% of all the exercises given to students. So, and the key here is 40%. So you're supposed to, when you define requirements, function is like what your system is doing, right? But then there are so many ways to do that thing, right? For this, to teach with scenarios, you can teach with only scenarios. Like all the your teaching method can be with scenarios. But actually, in the real world scenario, you might teach with only 40% of the time, and then 60% of the time you might teach vocab, or you might teach um, by giving tests and stuff like that. So this is trying to be more specific with numbers.
Okay. Anyone want to pick something else from this and try and more Cassie?
Like in the end, like over here, when you do a lesson, it'll say like how much time and how many questions you got correct. Maybe it can be like takes 1 second to load feedback.
Mm-hmm.
Yeah, okay. So the feedback, okay. Feedback, okay. This is from Kofa. Okay.
That is very, very good. Like you want your system to be able to perform with a certain threshold. And first it has to give feedback, but how well should it give feedback? In this case, it is giving feedback within 1 second.
Let's try.
Okay, so what's your name? Ping. Ping's gave some performance requirement for producer sound.
Okay.
Okay,
This sounds good stuff. What is the example of inside? Ah,
so that is not, it is a KPI, but maybe for the user, not the system.
for example, can be you produce a sound that is no larger than 20 decibels or something like that. It's about that verb. You want to qualify that verb, for example.
For your system,
For your system.
not yet for the user. That's something that you can think about later, but it's not necessarily for your system.
Maybe we move on to the next one. And
Yeah.
get some-
Do you have questions or do you want to answer?
Say, oh,
If you don't have one, but if you have a question, raise your hand. Yes,
okay.
I have a question about the robot example.
right, yes,
When you say cost effective, is it non-functional, right?
yes.
So my question is that if I say it's reduce the cost to be lower than human labor, would it be functional?
I think it would still be non-functional because it's not what the robot actively does. Yeah. So
It's basically doing
yeah, it has to be a function. Good question.
Let's do quickly the last one, maybe.
The last one, non-functional.
Can you think of anything that's good to have that's not like a function, not like a verb? Okay. Easy to use. Oh, okay. What else? Cream and then only.
flexible. Okay. And the animation. It has animation.
Could be kind of functional.
Yeah,
Or past animation.
it's like robotic animation.
So maybe it's more like attitude. Okay, but hopefully you get a sense of these examples. Well, we'll push this for later, maybe the exercise.
Yeah.
And then we have about 15 minutes before the break. We'll maybe do another exercise. Okay.
Okay, so another the next element of systems engineering is functional architecture. It is a representation of how your system's functions are going to interact with each other. So it's usually a flow diagram. So an example here for a reforestation robot would be this. And we usually divide the architecture into three parts. The first part is the input. The middle part is the system, what does it do? And the last part is your output. So here, for reforestation robot, the inputs are the seedlings, um, camera data, and the map of where you are going to be planting. In your system, it will show how you're using your inputs to do your functions. So here, the robot has to use the map of the site to plan a path of where it's going to run, and then it will combine the map information and the camera data into the function of navigating along the path, and also help determine where to stop in order to plan. And then it is going to dig a hole. After it digs a hole, it's going to use the input of a ceiling to insert the ceiling into the hole. And then afterwards, it's going to compress and close the hole. After that, we get an output. So this is a simplified version. Obviously, a real robot would be much more complicated. And the actual functional architecture looks something more like this. I won't go over everything with you, but one example is that here, um, when you actually plant a robot, when the robot actually plant a tree, it would actually try to attempt to dig a hole because the ground might have rocks underground that the robot's camera might not be able to see in the beginning. So it's going to attempt digging a hole, but uh, if it's not successful, meaning that it hits a rock, it's going to go through this step instead. Is it successful? If it's not successful, it comes back here. It's going to determine a next planting spot. And afterwards, it will attempt to dig a hole again. And if it's successful, it will plant a tree and then go through the whole process in order to plant the tree. Okay, so this is how functional architecture usually is.
In a way, kind of like if you think about the first two sessions, right? This is kind of similar. It's like a hybrid of process flow diagram and efficient tree together, right? You learn how to do input to output from session one, and last time, this time, you also learn about efficient trees. By the way, in your assignment, you don't have to be this detailed, but at least show us some effort. So not just like one component, for example.
Maybe something like this.
Yeah, I think something like this would be fine. To show that there's like, multiple parts, they do multiple steps and so on.
And how they are connected. Yeah. Okay, so is there any question?
Any questions on functional architecture?
We're gonna try to
Let's do a Duolingo. So what do you guys think would be? So maybe we'll do the same thing. Pinun kind of laid out. Right? We have input, system, and output. What do you guys think would be the input to this system? And should we think of it as an input from the user for an input from a developer trying to build this?
Somebody
Yeah.
Uh,
Cut.
is that a question?
Can I suggest the inputs?
Yeah.
Is it the same thing as the mark scenario with Duolingo?
Sure.
So like for the inputs, it might be like trip info, location, and Mark's goal, and like user level and history, like audio input.
So I think it's my question looking into like, should we think of inputs as like something we request from customers, or it should be more inputs for us to build the tool?
It should be input for us to build the tool. In order for us to build language learning app, what kind of inputs do we need? Sorry, what's your need? Vicky, okay. So Vicky's input is more related to the user. We have to have a system first before we care more about users' input. For now, what input do we want in order to build this system?
It's a great answer. We'll try to add you your software later on. So, Noah.
The number of words they were to learn in a week.
Oh,
Not necessarily yet. Like it's still tied to the user, but right now we are trying to build this system.
I think we got it. Questions. So the questions and answers that we would show.
Yeah.
So we need like some sort of bank of questions and answers. Do you have any examples? Yeah.
So in order for a system to be able to teach a language, we have to provide with like a language alphabet.
Something language. Okay. Alphabets.
Like grammatical structure of the language. Anything else?
CK.
Users proficiency.
I'm not sure. I don't think we need that yet. Like, try not to think of the user right now. Try to think of the app. How would we build a system that would teach a language?
See?
I think you could think about like the different games or the different modes of test.
With the questions and answer. Test. I think earlier we said, from you said we want to learn pronunciation, right? So maybe the input has to be the pronunciation itself. We have to record audio to put into the game. Pronunciation.
The words. And last one I want to add is like the words and their definitions.
Okay. We want to move on to the system.
So the system box here is more it's very similar to the functions that we come up with. We are going to be using all these inputs in order to make the system do what we want.
If you want to give one example as a starting point.
So we wanted to teach a language.
Okay.
So we can teach a language.
So it's very similar to functional requirements.
Yeah, it's pretty much your functional requirement.
This means I think some of the answers, like from Vicky earlier, or from people make sense, right? Vicky here, as you can say, you can ask people for information as one of the functions of the set. Okay, Cream.
Shape the answer.
Okay.
Any
Good.
okay, what kind of information? Yeah, the user's progress. Was that? Okay, store user data.
Yes. Record the pronunciation. I guess now you can speak into the app, right? I'll put it with store data, store answer. So what for that?
Right.
That's amazing. Like you adapt to it, right? Okay, random. Oh, okay. You now want to hit me because this is supposed to look like a process flow diagram. So how would you try to do it?
So, just now we got a lot of answers related to users. One input that we can have is users information.
VP had this next to yes, user info.
And then now they are supposed to connect with each other, right? So, um,
Ah, okay. So for example, user info, right?
they're using
So user info
going
and go into
to or
store data. This one. Store data.
and I think like the information about languages and pronunciation can go to help with checking the answer
Ah,
and teach the language.
okay. So in a way, it's almost like connecting your inputs into these in terms of making a flow, right? You can start off as like a bullet point like this, but you'll be like, okay, not every step need to use everything. So you try to connect them together.
But this is a good exercise because if at the end something doesn't connect to anything else on your flow chart, it might not be necessary, or maybe your functions are not complete. Okay, let's think quickly of a few outputs here that you want from this system. This
Metrics and feedback.
metric and feedback. Yes, it can give out some output, give feedback, or just feedback.
Okay. So you feel like accuracy, score, proficiency, and something.
Maybe when you want it to pronounce the word, you can make a voice the sound for pronunciation. For pronunciation.
Sorry, I don't completely understand. Can you repeat it?
So maybe we want the system to do the pronunciation for each word. Maybe want to say the word to us.
Okay, as an output.
Yes.
Okay.
So it's a part of the teach language we feel about the okay. What's the language? That's not feedback. Cream. Oh, cream. Pretty rich feedback. Yes. Street art, right? I think all same vibes. No need.
It's I don't know.
Right. Also, I think what Nani said, it seems to be more like a loop within the system. Right? It seems like it's still inside of the process. You see some answer, we give you a better question. I guess output would be more like things towards the end.
Yeah.
Just do the last two, review and the part. Notification, you doing. So coming from which one of these do you think we should give notification? For update information, okay. So give notification. Can you show us some, give us maybe some more examples? Let's do Noah first before we get.
Continued user engagement.
You know, Noah, let me give some examples of what you think the output should look like. Sorry, I think. You can like explain for me.
So I think maybe Tupac and I will give a whole new example of all this because when you think of a functional architecture, things have to connect and kind of flow Right now, some things connect, but don't necessarily flow together to give out outputs. And I don't want you to be more confused. So we're gonna give one possible answer to Duolingo.
Okay, what's your
Okay, the new board.
Oh, okay, you're blind, Mom.
So
Living.
example input of this system would be kind of like a dictionary of languages. Because we want the system to be able to teach a language, so it needs to be able to know the meanings of different words. And then the next input would be the language grammatical structure.
Okay.
And the last one would be alphabets.
Okay.
And in the system, it's going to teach users languages, give user exercises, and then it will correct users mistakes.
Okay.
Okay, and so let's see how all these things are connected to each other. So in order to use a language, in order to teach a language, you need all the inputs.
Okay.
And to give exercises, you will, for example, you need the grammar. And then in order to catch mistakes, it also needs the grammar and the dictionary. And the flow here in the system, first it teaches the language to the user, and then it gives the exercise. And then after the user completes the exercise, the system will catch any mistakes. And in here, you can say give feedback. And then it will be a flow. And at the end, the output is going to be, like in this case, it's going to be very simple. It will be the user will learn a language. Does anyone have any questions on this architecture? When you do your own architecture, try to make it quite simple and make sure that they connect to each other.
Right. Okay, let's take a 15 minutes break. Please try to come back. So what time is it now? It's 6:36. Please try to come back. Let's do 14 breaks again, 20 minutes. Let's start at 50. So that we can give you more time at the end before finals.
Professor Burke, can I still say something, please?
Oh yeah.
To